Section 14.3, Configuration Management with Kustomize. Kubernetes provides many useful features for running cloud-native applications. Still, it requires writing several YAML manifests, which are sometimes redundant and not easy to manage in a real-world scenario. After collecting the multiple manifests needed to deploy an application, we are faced with additional challenges. How can we change the values in a config map depending on the environment? How can we change the container image version? What about secrets and volumes? Is it possible to update the health probe's configuration? Many tools have been introduced in the last few years to improve how we configure and deploy workloads in Kubernetes. For the Polar Bookshop system, we would like a tool that lets us handle multiple Kubernetes manifests as a single entity and customize parts of the configuration depending on the environment where the application is deployed. Kustomize, Kustomize.io, is a declarative tool that helps configure deployments for different environments via a layering approach. It produces standard Kubernetes manifests, and it's built natively in the Kubernetes CLI, kube control, so you don't need to install anything else. Note: other popular options for managing deployment configuration in Kubernetes are Wirt from the Carvel suite, see this link, and Helm, helm.sh. This section will show you the key features offered by Kustomize. First, you'll see how to compose related Kubernetes manifests and handle them as a single unit. Then I'll show you how Kustomize can generate a config map for you from a property file. Finally, I'll guide you through a series of customizations that will apply to the base manifests before deploying workloads in a staging environment. The next chapter will expand on that and cover the production scenario. Before moving on, make sure you still have your local Minikube cluster up and running and that the Polar Bookshop backing services have been deployed correctly. If you don't, run /createcluster.sh from Polar Deployment /Kubernetes /platform /development. Note: the platform services are exposed only within the cluster. If you want to access any of them from your local machine, you can use the port forwarding feature you learned about in Chapter 7. You can either leverage the GUI provided by Octant or use the CLI, kubectl port forward service /polar postgres 5432. Now that we have all the backing services available, let's see how we can manage and configure a Spring Boot application using Kustomize. Section 14.3.1. Using Kustomize to manage and configure Spring Boot applications. So far, we've been deploying applications to Kubernetes by applying multiple Kubernetes manifests. For example, deploying catalog service requires applying the config map, deployment, and service manifests to the cluster. When using Kustomize, the first step is composing related manifests together so that we can handle them as a single unit. Kustomize does that via a customization resource. In the end, we want to let Kustomize manage, process, and generate Kubernetes manifests for us. Let's see how it works. Open your catalog service project, catalog service, and create a customization.yml file inside the Kates folder. It will be the entry point for Kustomize. We'll first instruct Kustomize about which Kubernetes manifests it should use as a foundation for future customizations. For now, we'll use the existing deployment and service manifests.
Listing 14.4. Defining the base Kubernetes manifests for Kustomize.
You might be wondering why we didn't include the config map. I'm glad you asked. We could have included the configmap.yml file we created earlier in the chapter, but Kustomize offers a better way. Instead of referencing a config map directly, we can provide a property file and let Kustomize use it to generate a config map. Let's see how it works. For starters, let's move the body of the config map we created previously, configmap.yml, to a new application.yml file within the Kates folder.
Listing 14.5. Configuration properties provided via a config map.
Then delete the configmap.yml file. We won't need it anymore. Finally, update the customization.yml file to generate a catalog config map starting from the application.yml file we just created.
Listing 14.6. Getting Kustomize to generate a config map from a property file.
Note: in a similar way, Kustomize can also generate secrets starting with literal values or files. Let's pause for a moment and verify that what we have done so far works correctly. Your local cluster should already have your catalog service container image from before. If that's not the case, build the container image, /gradle w boot build image, and load it into Minikube. Minikube image load catalog service -- profile polar. Next, open a terminal window, navigate to your catalog service project, catalog service, and deploy the application using the familiar Kubernetes CLI. When applying standard Kubernetes manifests, we use the F flag. When applying a customization, we use the K flag.
See this code?
The final result should be the same as we got earlier when applying the Kubernetes manifests directly, but this time Kustomize handled everything via a customization resource. To complete the verification, use the port forwarding strategy to expose the catalog service application to your local machine. kubectl port forward service / catalog service 9001/80. Then open a new terminal window and ensure that the root endpoint returns the message configured via the config map generated by Kustomize.
See this code?
Config maps and secrets generated by Kustomize are named with a unique suffix, a hash, when they're deployed. You can verify the actual name assigned to the catalog config map with the following command.
See this code?
Every time you update the input to the generators, Kustomize creates a new manifest with a different hash, which triggers a rolling restart of the containers where the updated config maps or secrets are mounted as volumes. That is a highly convenient way to achieve an automated configuration refresh without implementing or configuring any additional components. Let's verify that it's true. First, update the value for the polar.greeting property in the application.yml file used by Kustomize to generate the config map.
Listing 14.7. Updating the configuration input to the config map generator.
Then apply the customization again, kubectl apply -k cates. Kustomize will generate a new config map with a different suffix hash, triggering a rolling restart of all the catalog service instances. In this case, there's only one instance running. In production, there will be more. The fact that the instances are restarted one at a time means that the update happens with zero downtime, which is what we aim for in the cloud. The catalog service root endpoint should now return the new message.
See this code?
If you're curious, you could compare this result with what would happen when updating a config map without Kustomize. Kubernetes would update the volume mounted to the catalog service container, but the application would not be restarted and would still return the old value. Note: depending on your requirements, you might need to avoid a rolling restart and have the applications reload their configuration at runtime. In that case, you can disable the hash suffix strategy with the disable name suffix hash, true generator option, and perhaps rely on something like Spring Cloud Kubernetes Configuration Watcher to notify the applications whenever a config map or secret is changed. When you're done experimenting with the customized setup, you can stop the port forwarding process, Ctrl+C, and undeploy catalog service, kubectl delete -k cates. Since we moved from plain Kubernetes manifests to Kustomize, we still need to update a couple of things. In Chapter 7, we used Tilt to achieve a better development workflow when working locally on Kubernetes. Tilt supports Kustomize, so we can configure it to deploy applications via a customization resource rather than via plain Kubernetes manifests. Go ahead and update the Tilt file in your catalog service project as follows.
Listing 14.8. Configuring Tilt to deploy catalog service using Kustomize.
Finally, we need to update the manifest validation step in the commit stage workflow for catalog service, or it will fail the next time we push changes to GitHub. In your catalog service project, open the commitstage.yml file, GitHub Workflows, and update it as follows.
Listing 14.9. Using kubeval to validate the manifests generated by Kustomize.
So far, the most significant benefit we got from Kustomize is the automatic rolling restart of applications when a config map or secret is updated. In the next section, you'll learn more about Kustomize and explore its powerful features for managing different Kubernetes configurations depending on the deployment environment. Section 14.3.2. Managing Kubernetes configuration for multiple environments with Kustomize. During development, we followed the 15-factor methodology and externalized the configuration for each aspect of an application that could change between deployments in different environments. You saw how to use property files, environment variables, configuration services, and config maps. I also showed you how to use Spring profiles to customize the application configuration based on the deployment environment. Now we need to take a step further and define a strategy to customize the entire deployment configuration depending on where we deploy an application. In the previous section, you learned how to compose and process Kubernetes manifests together via a customization resource. For each environment, we can specify patches to apply changes or additional configurations on top of those basic manifests. All the customization steps you'll see in this section will be applied without changing anything in the application source code, but using the same release artifacts produced earlier. That's quite a powerful concept and one of the main features of cloud-native applications. The Kustomize approach to configuration customization is based on the concepts of bases and overlays. The K8s folder we created in the catalog service project can be considered a base, a directory with a customization.yml file that combines Kubernetes manifests and customizations. An overlay is another directory with a customization.yml file. What makes it special is that it defines customizations in relation to one or more bases and combines them. Starting from the same base, you can specify an overlay for each deployment environment, such as development, test, staging, and production. As shown in Figure 14.3, each customization includes a customization.yml file. The one acting as the base composes together several Kubernetes resources like deployments, services, and config maps. Also, it's not aware of the overlays, so it's completely independent of them. The overlays use one or more bases as a foundation and provide additional configuration via patches.
Figure 14.3. Kustomize bases can be used as the foundation for further customizations, overlays, depending on the deployment environment.
Bases and overlays can be defined either in the same repository or different ones. For the Polar Bookshop system, we'll use the K8s folder in each application project as a base and define overlays in the Polar deployment repository. Similar to what you learned in Chapter 3 about application code bases, you can decide whether to keep your deployment configuration in the same repository as your application or not. I decided to go for a separate repository for a few reasons. It makes it possible to control the deployment of all the system components from a single place. It allows focused version control, auditing, and compliance checks before deploying anything to production. It fits the GitOps approach, where delivery and deployment tasks are decoupled. As an example, Figure 14.4 shows how the customized manifests could be structured in the case of catalog service, having bases and overlays in two separate repositories.
Figure 14.4. Customized bases and overlays can be stored in the same repository or two separate ones. Overlays can be used to customize deployments for different environments.
Another decision to make is whether to keep the base Kubernetes manifest together with the application source code or move them to the deployment repository. I decided to go with the first approach for the Polar Bookshop example, similar to what we did with the default configuration properties. One of the benefits is that it makes it simple to run each application on a local Kubernetes cluster during development, either directly or using Tilt. Depending on your requirements, you might decide to use one approach or the other. Both are valid and used in real-world scenarios. Patches versus templates. Kustomize's approach to customizing configuration is based on applying patches. It's quite the opposite of how Helm works, helm.sh. Helm requires you to template every part of a manifest that you would like to change, resulting in non-valid YAML. After that, you can provide different values for those templates in each environment. If a field is not templated, you can't customize its value. For that reason, it's not rare to use Helm and Kustomize in sequence, overcoming each other's shortcomings. Both approaches have pros and cons. In this book, I decided to use Kustomize because it's natively available in the Kubernetes CLI, it works with valid YAML files, and it's purely declarative. Helm is more powerful and can also handle complex application rollouts and upgrades that Kubernetes doesn't support natively. On the other hand, it has a steep learning curve. Its templating solution has a few drawbacks, and it's not declarative. Another option is YT from the Carvel suite, see this link. It provides a superior experience with support for both patches and templates, it works with valid YAML files, and its templating strategy is more robust. It takes a bit more effort to get familiar with YTT than Kustomize, but it's worth the effort. Because it treats YAML as a first-class citizen, YTT can be used to configure and customize any YAML file, even outside Kubernetes. Do you use GitHub Actions workflows, Ansible playbooks, Jenkins pipelines? You can use YTT in all those scenarios. Let's consider catalog service. We already have the base deployment configuration composed with Kustomize. It's located within the project repository in a dedicated folder, catalog service/Kates. Now let's define an overlay to customize the deployment for staging. Section 14.3.3. Defining a configuration overlay for staging. In the previous sections, we used Kustomize to manage the configuration of catalog service in a local development environment. Those manifests will represent the base for multiple customizations applied for each environment as overlays. Since we'll define overlays in the Polar deployment repository while the base is in the catalog service repository, all the catalog service manifests must be available in the main remote branch. If you haven't done so yet, push all the changes applied to your catalog service project so far to the remote repository on GitHub. Note: as I explained in Chapter 2, I expect you have created a different repository on GitHub for each project in the Polar Bookshop system. In this chapter, we're working only with the Polar deployment and catalog service repositories, but you should have also created repositories for Edge service, Order service, and Dispatcher service. As anticipated, we'll store any configuration overlay in the Polar deployment repository. In this section and the following ones, we'll define an overlay for the staging environment. The next chapter will cover production. Go ahead and create a new Kubernetes applications folder in your Polar deployment repository. We'll use it to keep the customizations for all the applications in the Polar Bookshop system. In the newly created path, add a catalog service folder that will contain any overlay for customizing the deployment of catalog service in different environments. In particular, we'll want to prepare the deployment in staging, so create a staging folder for catalog service. Any customization, base or overlay, requires a customization.yml file. Let's create one for the staging overlay of catalog service, Polar deployment/Kubernetes/applications/catalog service/staging. The first thing to configure is a reference to the base manifests. If you've followed along, you should have your catalog service source code tracked in a catalog service repository on GitHub. A reference to a remote base needs to point to the folder containing the customization.yml file, which is Kates in our case. Also, we should refer to a specific tag or digest for the version we want to deploy. We'll talk about release strategies and versioning in the next chapter, so we'll simply point to the main branch for now. The final URL should be something like this. For example, in my case, it would be this.
Listing 14.10. Defining an overlay for staging on top of a remote base.
Note: I'll assume that all the GitHub repositories you created for Polar Bookshop are publicly accessible. If that's not the case, you can go to the specific repository page on GitHub and access the settings section for that repository. Then scroll to the bottom of the settings page and make the package public by clicking the Change Visibility button. We could now deploy catalog service from the staging overlay using the Kubernetes CLI, but the result wouldn't be different than using the base directly. Let's start applying some customization specifically for staging deployments. Section 14.3.4. Customizing environment variables. The first customization we could apply is an environment variable to activate the staging Spring profile for catalog service. Most customizations can be applied via patches following a merge strategy. Much like Git merges changes from different branches, Kustomize produces final Kubernetes manifests with changes coming from different customization files, one or more bases, and an overlay. A best practice when defining Kustomize patches is to keep them small and focused. To customize environment variables, create a patch.env.yml file within the staging overlay for catalog service, Kubernetes applications, catalog service staging. We need to specify some contextual information so Kustomize can figure out where to apply the patch and how to merge the changes. When the patch is for customizing a container, Kustomize requires us to specify the kind and name of the Kubernetes resource, that is, deployment, and the name of the container. This customization option is called a strategic merge patch.
Listing 14.11, a patch for customizing environment variables.
Next, we need to instruct Kustomize to apply the patch. In the customization.yml file for the staging overlay of catalog service, list the patch nv.yml file as follows.
Listing 14.12, getting Kustomize to apply the patch for environment variables.
You can use this same approach to customize many aspects of a deployment, such as the number of replicas, liveness probe, readiness probe, graceful shutdown timeout, environment variables, volumes, and more. In the next section, I'll show you how to customize config maps. Section 14.3.5, Customizing config maps. The base customization for catalog service instructs Kustomize to generate a catalog config map starting from an application.yml file. To customize the values in that config map, we have two main options: replace the entire config map or overwrite only the values that should be different in staging. In this second case, we could generally rely on some advanced customized patching strategy to overwrite specific values in the config map. When working with Spring Boot, we can take advantage of the power of Spring profiles. Instead of updating values in the existing config map, we can add an application staging.yml file, which we know takes precedence over application.yml when the staging profile is active. The final result will be a config map containing both files. First, let's create an application staging.yml file within the staging overlay for catalog service. We'll use this property file to define a different value for the polar.greeting property. Since we'll use the same Minikube cluster from earlier as the staging environment, URLs to backing services and credentials will be the same as in the development environment. In a real-world scenario, this stage would involve more customizations.
Listing 14.13, staging-specific configuration for catalog service.
Next, we can rely on the config map generator provided by Kustomize to combine the application staging.yml file defined in the staging overlay with the application.yml file defined in the base customization within the same catalog config map. Go ahead and update the customization.yml file for the staging overlay as follows.
Listing 14.14, merging property files within the same config map.
That's it for config maps. The following section will cover how you can configure which image name and version to deploy. Section 14.3.6, Customizing image name and version. The base deployment manifest defined in the catalog service repository, catalog service/kate/deployment.yml, is configured to use a local container image and doesn't specify a version number, which means the latest tag is used. That's convenient in the development phase, but it doesn't work for other deployment environments. If you followed along, you should have your catalog service source code tracked in a catalog service repository on GitHub and a ghcr.io your _GitHub username catalog service latest container image published to GitHub container registry, as per the commit stage workflow. The next chapter will cover release strategies and versioning. Until then, we'll still use the latest tag. Regarding the image name, though, it's time to start pulling container images from the registry rather than using the local ones. Note: images published to GitHub Container Registry will have the same visibility as the related GitHub code repository. I'll assume that all the images we build for Polar Bookshop are publicly accessible via the GitHub Container Registry. If that's not the case, you can go to the specific repository page on GitHub and access the Packages section for that repository. Then select Package Settings from the sidebar menu, scroll to the bottom of the Settings page, and make the package public by clicking the Change Visibility button. Similar to what we've done for environment variables, we could use a patch to change the image that's used by the catalog service deployment resource. Since it's a very common customization and would need to be changed every time we deliver a new version of our applications, however, Kustomize provides a more convenient way to declare which image name and version we want to use for each container. Furthermore, we can either update the customization.yml file directly or rely on the Kustomize CLI, installed as part of the Kubernetes CLI. Let's try the latter. Open a terminal window, navigate to the staging overlay for Catalog Service, Kubernetes Applications, Catalog Service, Staging, and run the following command to define which image and version to use for the Catalog Service container. Remember to replace your _GitHub_ username with your GitHub username in lowercase.
See this code?
This command will automatically update the Kustomize.yml file with the new configuration, as you can see in the following listing.
Listing 14.15. Configuring the image name and version for the container.
In the next section, I'll show you how to configure the number of replicas to deploy. Section 14.3.7. Customizing the number of replicas. Cloud-native applications should be highly available, and Catalog Service is not. So far, we've been deploying a single application instance. What happens if it crashes or becomes momentarily unavailable due to a high workload? We would not be able to use the application anymore. Not very resilient, is it? Among other things, a staging environment is a good target for performance and availability tests. At a minimum, we should have 2 instances running. Kustomize provides a convenient way to update the number of replicas for a given pod. Open the Kustomize.yml file in the staging overlay for Catalog Service, Kubernetes Applications, Catalog Service, Staging, and configure 2 replicas for the application.
Listing 14.16. Configuring replicas for the Catalog Service container.
It's finally time to deploy Catalog Service and test the configuration provided by the staging overlay. For simplicity, we'll use the same Minikube local cluster we have been using so far as the staging environment. If you still have your Minikube cluster up and running from before, you're good to go. Otherwise, you can start it by running /create_cluster.sh from Polar deployment /Kubernetes/platform/development. The script will spin up a Kubernetes cluster and deploy the backing services required by Polar Bookshop. Then open a terminal window, navigate to the staging overlay folder for Catalog Service, Applications/Catalog Service/Staging, and run the following command to deploy the application via Kustomize.
See this code?
You can monitor the operations result via the Kubernetes CLI, kubectl get pod lapp equals catalog service, or the Octant GUI. Refer to Chapter 7 for more information. Once the applications are available and ready, we can check the application logs using the CLI.
See this code?
One of the first Spring Boot log events will tell you that the staging profile is enabled, just like we configured in the staging overlay via a patch. The application is not exposed outside the cluster, but you can use the port forwarding functionality to forward traffic from your local environment on port 9001 to the service running in the cluster on port 80.
See this code?
Next, open a new terminal window and call the application's root endpoint.
See this code?
The result is the customized message we defined in the application staging.yml file for the polar.greeting property. That's exactly what we were expecting. Note: it's worth noticing that if you send a GET request to 9001 books, you'll get an empty list. In staging, we haven't enabled the test data profile controlling the generation of books at startup time. We want that only in a development or test environment. The last customization we applied to the staging overlay was the number of replicas to deploy. Let's verify that with the following command.
See this code?
Kubernetes is designed to ensure the availability of each application. If enough resources are available, it will try to deploy the 2 replicas on 2 different nodes. If one node crashes, the application will still be available on the other one. At the same time, Kubernetes takes care of deploying the second instance somewhere else to ensure there are always 2 replicas up and running. You can check which node each pod has been allocated on with kubectl get pod o-wide. In our case, the Minikube cluster has only 1 node, so both instances will be deployed together. If you're curious, you can also try to update the application staging.yml file, apply the customization to the cluster again, kubectl apply k, and see how the catalog service pods are restarted one after the other, rolling restarts, to load the new config map with 0 downtime. To visualize the sequence of events, you can either use Octant or launch this command on a separate terminal window before applying the customization kubectl get pods lapp equals catalog service -- watch. When you're done testing the application, you can terminate the port forwarding process with Ctrl+C and delete the cluster with /destroy_cluster.sh from polar deployment /kubernetes/platform/development. Now that you've learned the fundamentals of configuring and deploying Spring Boot applications in Kustomize, it's time to go to production. That's what the next chapter is all about. Polar Labs. Feel free to apply what you've learned in this chapter to all the applications in the Polar Bookshop system. You'll need these updated applications in the next chapter, where we'll deploy everything in production. 1. Disable the Spring Cloud Config client. 2. Define a base customization manifest and update tilt and the commit stage workflow. 3. Use Kustomize to generate a config map. 4. Configure a staging overlay. You can refer to the Chapter 14/14n folder in the code repository accompanying the book to check the final result. See this link.